And now, we are going to introduce the primary dysfunctional analysis. They are inductive in nature as the reasoning aims at identifying the effects resulting of given causes. This is described in Chapter 3.4 and Part 2 of the reference book. Again, we can remember the previous slide presenting the whole corpus of methods and tools, which is divided into three parts: basic, static, and dynamic models. Now we are going to deal with the three primary inductive approaches, which are the preliminary hazard analysis, the failure mode effects and criticality analysis, and the hazard and operability study. The three of them are devoted to deal with single failures and, as said before, they aim to help the analyst to understand how the system works and to achieve high-level analyses. All these three inductive approaches share the same characteristics. First of all, they are qualitative approaches and easy to handle. They involve no complex theory and only need goodwill and common sense to be implemented. And, despite of their rather simplistic appearance, they are of impressive efficiency. It has to be noted that sometimes they can be extended to semi-quantitative analyses. As previously mentioned, the risk identification is the first step of the dysfunctional analysis. This is of utmost importance to be sure to analyze the relevant problem. As also previously said, inductive approaches are used to do that. Many methods are available and the main ones are the following. The PHA, that is, preliminary hazard analysis. The HAZOP, that is, hazard identification. The FMEA, that is, the failure modes, effects and criticality analysis. The HAZOP, that is, hazard and operability study. The analysis of accident scenarios, and so on. Even if it can be achieved by the analyst alone in his or her office, the maximum efficiency is achieved when specialists from the field who actually know what happens in operation are involved. They are essential for two different purposes: providing an in-depth understanding of the system behavior and achieving high-level dependability studies. This is often sufficient for simple systems, but this is an essential stage for complex or complicated systems. All the previous approaches proceed of the same inductive philosophy. They start from a specific state to see what happens at a more general level. This is a very old philosophical reasoning. More specifically, the reasoning starts from the occurrence of a given event, the value of a particular physical parameter or an individual component failure. And, from these causes, we infer what happens at the overall system level. Now let us look at how the preliminary hazard analysis can be handled. This approach aims to identify the hazard and then the potentially dangerous situations able to lead to incidents or accidents. It is undertaken by using a textual form with several standardized columns. The subsystem of the function under analysis. The operating phase which is considered. And the events able to lead to dangerous situations. Pre-established checklists are generally available in order to make this analysis easier. From this point, dangerous situations can be identified. The way how this can give a potential accident is analyzed. And the potential resulting accident is identified. Then the level of consequence can be assessed. And the preventive actions to prevent or mitigate the above accident can be analyzed. Finally, the last column is devoted to explain how the preventive actions are actually implemented. Let us continue with the accident scenario approach. It aims to identify and analyze the possible escalations after a hazardous event has occurred. Again, it is undertaken by using a textual form with several standardized columns. The system under analysis. The subsystem which is considered. And the accidental event which is likely to occur. From this point, the possible causes and the possible escalations can be identified. Verifying the available relevant detection means is very important at this stage. Then the prevention means can be examined, as well as the corrective actions to prevent or mitigate the above escalations. Finally, the last column is devoted to add comments when needed. HAZOP is another popular inductive approach. It proves to be very effective to deal with industrial processes. Its originality is that it is performed by a group of persons around a table. Again, they fulfill a textual form with several standardized columns. The system and subsystem under analysis. the function achieved by this subsystem, and the operating parameters involved. From this point, the possible deviations from the nominal situation are examined. This leads to identify the possible causes and to estimate the resulting consequences. Again, verifying that the relevant detection means are available is of utmost importance. Then the corrective actions have to be identified and noted. And, finally, the last column is devoted to add comments when needed. To finish with this gallery of inductive approaches, let us have a look at the failure mode and effect analysis, which is also another very popular approach of this type. It proves to be very effective to perform in-depth analysis of components' failure modes. Again, it is achieved by using a textual form with several standardized columns. The system and subsystem under analysis, the function achieved by this subsystem, and the component under analysis. Then each failure mode is considered, in order to identify the possible causes and consequences. Both consequences at local and system levels have to be identified. Again, verifying that the relevant detection means are available is of utmost importance. The originality of this approach is that it is possible to mention the probability and the level of consequence of the failure mode under study. This is the so-called criticality analysis. This allows to perform semi-quantitative analyses with this approach. Then, again, the last column is devoted to add comments when needed. As seen with the previous description, all these inductive approaches are based on very close bases. We are going to compare three of them hereafter. We have chosen to compare FMEA, HAZOP, and scenarios approaches. FMEA and HAZOP deal with single failures when the scenarios deals with sequences of events. On the slide we have now displayed the various columns previously described. We can see that the core of these approaches is the same: causes, consequences, and detection. Of course, their inductive nature belongs to this core. Then, if the purpose of these three approaches seems different, they are, in fact, very similar.